Hi, thank you for watching this tutorial video on the visual circuit with rolling vertical takeoff and rolling vertical landing in the AV-8B Harrier. So in this video, I'm not going to explain any specific concepts. I'm going to demonstrate to you what's expected of you in your assessment to prove your competency with the rolling vertical takeoff and the rolling vertical landing. Obviously, in a real world scenario, it's very rare that you would take off from a fob or a fob and go straight in the visual circuit. You'd normally depart straight out and go and do whatever operational task you have. Okay, so let's start with the cockpit setup. It's the most important thing for setting yourself up mentally and physically. So just coming down here, I'm just going to make sure my lighting setup is desired. And I'm going to raise myself up. So that's that, and then I'm going to come over to my MPCD and I'm going to set up my EHSD so that it's more readable in VR, and I'm going to hit the zoom button to bring the zoom in. Okay, and on the right MPCD I'm going to bring up the engine page because that's the first one I'm going to use, and now we're going to go straight into the pre-takeoff data assignment. So coming over here into the VRES page, we're going to overwrite the basic aircraft weight with the operational weight, which is 16,475 pounds. And the BDI to 16, that's your basic drag index. Obviously, that's more important for fuel endurance calculations by the crew section of the VRES computer. Not important here, but it's good to have that habit. Hitting stow, we're going to go into the outside air temperature, and we're going to set that to 29. Remember, if you're in a hangar or if it's a different time of day, you might have a different outside air temperature to what is set in the weather of the mission. We're going to set the field elevation to 0. And at the same time, we're going to bring the altimeter down to 0 to set QFE. Again, only applicable for training scenarios. Otherwise, you would always put the field elevation in, and you would always use QNH. Field data, so we know the runway distance is approximately 150 feet. Not 15, 150. Runway headings 338 degrees. And the ground winds 338 at 9 knots. And then we're going to go and get our vertical takeoff weight. So with water on, so wet, 21,080 pounds. We're at 3,800 pounds, so that is 1,700 over. Plus, I've got 1,000 pounds of stores, so that's 2,800. That's within the 4,000 pound ballpark figure. However, it will be a bit tight with those trees there. But we've got enough prepared surface, and then hopefully that's enough clearway for us to get up into the air. Again, you would, if you really needed to carry a significant amount of stores and you had a really short runway, you would sit down and you would calculate it before you got on the mission. Okay, next we're going to do the one finger checks. So I'm just going to return this MPCD back to the EHSD. One finger checks, I'm going to put the stow stop to 70 there. And I'm going to check that the nozzles are set to 70. Then I'm going to set the nozzles to 30. Perfect. Coming forward, I'm going to make sure that the nose wheel steering is in the anti-skid position. My flaps are in the stoval position. Combat water's on. Takeoff water's on. And then I'm going to make sure that I'm trimmed to 2 degrees nose down, which I am. And that should be everything for the one finger check. I'm not going to perform a 2 or a 5 finger check. In this case, it would be 5 finger because it's water on, just for the expedience of time. And one last thing I forgot is the course line, which is imperative for accurate circuit flying. So, a quick verbal run through of what's about to happen. In a moment, I'm going to perform the rolling vertical takeoff. I'm going to hold the brakes. I'm going to advance the power. At the skid, I'm going to release. I'm going to use the maximum amount of prepared surface here, so I'm blending the rolling vertical takeoff with the short takeoff. Obviously, if you were light enough, you would just wait until you hit 110% RPM and then you'd bring the nozzles back. Immediately afterwards, I'm going to pitch the nose up and bring the nozzles forward to perform the capture attitude technique to begin the transition. When the nozzles get to 25 degrees, I'm going to slightly retard the power to prevent the engine from being damaged, and then I'm going to do my touch checks. I'm going to clear the stow stop, and I'm going to put the water into the off position. I'm going to leave the flaps where they are, and I'm going to leave the nozzles at 25 degrees. I'm going to level out at 1,000 feet. I'm going to trim on AOA for 10 to 12 units of AOA straight and level. I'm then going to perform the turn. During the turn, I'm going to look to be 0.3 to 0.4 miles on the delta distance halfway through the turn, and I'm going to look to roll out parallel to the runway at between 0.8 and 1.0 nautical miles. Once I'm rolled out, I'm going to almost immediately bring the nozzles back to 60 degrees, and I'm going to retrim myself for 10 to 12 units AOA in straight and level flight. Once I'm abeam with the landing point, I'm going to time for 10 seconds as I have less than a 10 knot headwind, and then I'm going to start my turn. During the turn, I'm going to gate myself. I want to be between 500 and 600 feet on the 90. Once I reach the 90, I'm going to bring the nozzles back to 77 degrees. I'm then going to next look to be at the key at 325 feet at 0.6 miles, and then I will perform the rolling vertical landing. Okay, so let's take the parking brake off, clear the master caution, hold the brakes, let's add the power. There's the skid and release, let the aircraft roll forward, bring the nozzles back to 70, bring the nose up, and capture attitude technique. There's 25, power, stow stop, water. Allow the aircraft to continue to climb. Check we're on the center line. Don't let the aircraft climb away from you too rapidly, because then as soon as you level out, you'll pull the power back and the aircraft will start to descend. Adjusting the power upward to keep AOA and straight and level. And slightly bring the power back and trimming nose up. Still trimming nose up. There we go. Okay, let's start the turn, so a good lookout. And we're clear, let's start the turn. A little bit of extra power to compensate for the lift vector not being directly opposing gravity. 0.1, 0.2, lookout attitude instruments, 0.3, 0.7, bit of rudder to help us get around. And we're going to go straight and level just now, and I'm going to bring the scale up. There we go, so a little bit wide. So we're just going to point the nose in. 1.2, a little bit wide, let's point the nose in. Okay, bring the power back, there's my landing, my DHLA. So I'm going to bring the nozzles back to 60. Don't touch the power, bring the nose down to counteract the balloon. Now adjust the power and trim. And we're at 1 nautical mile, delta distance, we're not quite abeam yet. Adjusting the power to maintain on speed, straight and level. And we're going to come parallel, 0.9, perfect. And there we are, we're abeam, so at 15 we're going to go up to 25. And we're going to start our turn now, just in the power, 10 to 12 units of AOA. We're looking to be at 500 feet on the 90. See how high my rate of descent is there. We're a little bit high. We're going to bring the nozzles back to 77 degrees. We're going to add some power. Visual check of the DHLA. Bit of rudder to help us come around the remainder of the turn, and we're looking to be at 325 feet. Watch your airway during the final part of the turn. 0.9 miles at 450 feet, and I'm just retrimming. Ground speed 60 knots, perfect, and Airway's a little bit high.
Altitude.
Just right for the DHLA. 0.6 at 320. Perfect. And I'm just going to fly as though I'm flying over the designated landing area. And now I'm going to adjust my aim point, keep my airway. Just putting it on the nose there. Which is hot on the horizon. No more than 500 feet per minute. Hold the brakes, close the throttle. Okay, so obviously in this scenario, I didn't touch the nozzles as we got in close. However, in a real world scenario, you might choose to bring them to the hover stop or even the braking stop to help you slow down and to get a little bit more jet-borne lift as you come in the terminal stage of the approach. That can really help you reduce the amount of surface area that you're using up. I hope that you found this video useful. Obviously, there were a few small errors, such as the AHSD not giving me an accurate course line because I'd flown so far away trying to get up to 1,000 feet. And also, during that final part of the turn, I misjudged the turn and had to turn quite tightly at the end. So I nearly bust the airway. So not the finest example of the final turn for the rolling vertical landing. If you do have any questions about anything you've seen today, please contact me. Thank you very much.